Section 5.4 tree diagrams. The tree diagrams is a useful way of finding the probability. We'll discuss two examples a bit differently. First of all, assume, one is width replacement. And we'll discuss the other one without replacement. Assume we have 4 blue marbles and 3 green marbles. Then probability of getting blue, I will take B as blue. Now 4 out of 7. Probability of getting green, that is going to be 3 out of 7. So assume that 2 times I pick a marble, then I can show this incident from a tree diagram. As you know, this is let's start with green, blue, then again the second begin green, blue, green and blue. So we know this is green is 3 over 7, blue is 4 over 7, 3 over 7, 4 over 7, 3 over 7, 4 over 7. Then what is the, I will name this is G1, B1, the first pickup, and G2, B2. So this is the second pickup. So probability of getting G1 and G2, we are writing PG1 times PG2, that is 3 over 7 times 3 over 7. So this one, probability of G1 and, so I put the intersection sign B2. So G1 B2, so this is the N, G1 intersection B2. So same as, so this is P G1 times P B2. So this is 3 over 7 times 4 over 7. So this value is 9 over 21, 49, and this value is 12 over 49. So likewise, we can find those two as well. Now, the second one, we will do a pickup first time. So this is going to be with replacement. This is the first take in. There are, okay, I will discuss everything together. 3 and 4 blue balls. Now, first picking. G1 and B1. So probabilities as usual, 3 out of 7 and 4 out of 7. Now the second picking, G2, B2, G2, B2. Now, if you pick green one first in here, then you are not going to put that green one without without replacement. So I'm going to talk on this one without. So I'm not going to replace it back without replacement. So assume if you get a green one, then you have two greens and four blues. Now total is 6. Then getting green is 2 out of 6 and getting blue is 4 out of 6. Now it is changing, and um, if you manage to get a blue, then there are only 3 blues. Then green 3 and blue 3, total still 6. Then getting green is 3 out of 6, getting blue is 3 out of 6. Now probability of G1 and G2 or G1 intersection G2, then this is going to be PG1, probability of G1, and multiply by probability of G2 given G1. G2 given G1. And here probability of G1 and B2 intersection. Yes. So then PG1 and then probability. So this probability is probability G2 given G1. So that is the probability. This one is going to be probability B2 you will get before first G1. So B2 given G1. Here, yes, you can write this is PG2 and this is PB2, this probability. But here this is PG1 and same mass here. Probability of B1 intersection G2. So this is going to be PB1. This probability is PB1. So this is PG1. So this is PG1, PB1. This is as it is. So this is this probability 4/7 PB1. So PB1 times probability G2 given B1. G2, you come to G2 via B1. So then just to get an idea, but don't use that via, but to get probability B1 intersection B2, it means probability PB1, then the multiply by your multiplication like this, then probability, what is this probability for? Probability B2 but before B1. So B2 given B1, that's why I will write given B1. Now here also you can write that, but it is equal to, so you can write here P G2 given G1, but PG2 mm, Pg2 given G1 is Pg1 because there is no influence. The second taking not is not depend on the first taking, but here definitely the second one is effect. So probability of G1 intersection G2 Pg1, then Pg2 given G1. So if I pick up this one, Pg1, I'll write in this one Pg1 intersection. Okay, instead of that I will go mix Pg1 given B2 is Pg1 times G2 G1 B2. So G1 given B2. In other way, Pg1 given B2 is Pg1 intersection B2 over Pg1. I think I erroneously wrong this one. This is Pb2 G1. Yeah, B2 first given G1. So then this is B2 G1. B2 given G1. So B2 given G1 we can find the intersection and Pg1. So this is a conditional probability. So this will condition on B2 condition on G1. So B2 influenced by G1 in this case. Yeah, I just divide by Pg1 both sides. So just to make this one as a subject. So if I given P, C given D, how you can write P, C intersection D and divide by 1. Whatever the given, so P, D. So you can see PB2 given G1 is this intersection of G1 and B1 and divide by PG1. This one. Same way. Divide by probability of D. Intersection of this one and probability of alpha given beta. So probability of intersection of alpha and beta and then divide by probability of probability probability of beta. This is another example. Assume that there are flower seeds. Out of that, 3/4 uh, were treated, and 1/4 no. And out of that, 3/4 flowering. The probability of flowering is 8 out of 10. None is 2 out of 10. And here the probability of flowering is 6 out of 10 and none it is 4 out of 10. So we'll show in this tree diagram. So there are two type of seed. One is treated and non-treated tree complements and the other seed and the flower. So it is say F and F complement non-flower. So F and F complement. So Treated there are 3 over 4, non-treated 1 over 4. Out of that 10 over 8 over 10 flowering and 2 over 10 none. And here 1 over 10 flower and 4 over 10 none. So this is F complement, not belongs to. So now this is probability of T. This is probability of T complement. This is probability of F given T. This is probability of uh, F complement given T, and this is probability of F given T complement, and this is probability of F complement given T complement, this one.